Hi, I'm Gary, and I want to show you how I use Cloudy. Hi there. In this video, we're going to talk about the species we can use in Cloudy and how you can change them and control how many lines we produce. If you're happy with the way we have set up Cloudy, you can skip this video. So the default number of levels and models that we include when you run Cloudy, like the H2 molecule, how many levels of CO, or how you treat carbon 4, is a compromise for completeness and speed. You can adjust what levels we include, what species we include. We have a number of different databases, so there's options where you can control all of that, and we're going to go into them right now. It all begins with a file linelabels.in, which is in the docs directory, which is near the top of the download. So the download has data then docs. Inside the docs directory, you find linelabels.in. So if you run that file, we include the files in the distribution, but if you change the species or the size of the levels, you may wish to rerun linelabels.in to get a report for your current setup. So it generates a report. This is the contents in the file. So the black lines are real commands, the red lines are comments. The test does not do much. It runs a smoke test. That's a quick way of getting Cloudy to set itself up and check it's okay. And then there are four commands, and we're going to go through them one by one, and they generate reports for what Cloudy is doing. Save species all labels is one of the commands, and what it does is generate a report that gives you all the species Cloudy knows about. Remember, there's two different things. There's a spectrum, which is a collection of photons, maybe carbon 2, and then there's a species, and that's the baryon that made it. That would be C plus. And so we use that language. So this section of Hazy describes it. This is a sample of the output. So there's two columns. The top of the file is here, and this is the bottom of the file over here. So the first column gives the species name. So this is the baryon. So atomic hydrogen would be H. Uh, H3 plus is an important molecular ion for determining the cosmic ray density of the galaxy. Atomic lithium. Now over here, we're getting up into the X-ray. So here's some high ionization stages of iron. So we have this notation with the element name plus and then a number. And then the second column in each gives the database that we're going to use to treat emission from that ion. So you'll notice many of these, for instance, these molecules, H3 plus, H2 plus, don't have a database here. That means there's no existing model of the internal structure. But for many of these, there is a model. So you see here, if you're interested in beryllium plus, we would use our Stout database to get you the beryllium plus emission. For these stages of ionization of iron, Chianti is exceptionally good for atomic data related to solar physics, which is their emphasis. So these ion stages of iron are very important in sun. We use these for many of these ions. You can change which database you use. This is a judgment call. Each baryon makes an emission or absorption spectrum, and in most cases, we have a model for that. That's the internal structure of the database. So there are four main databases we have. The Stout database is our in-house Cloudy database that we've been developing since 2015. Chianti is a very famous, respected database that was originally intended for solar physics and is being maintained. So this 2024 paper is the last release of Chianti. The Lambda database comes from Leiden University in the Netherlands and is intended for molecules or for atoms that are found in PDRs in particular. So we use them for the internal structure of many of the molecules we include. And finally, the 1 and 2 electron systems are a special case in Cloudy. If you remember the energy level diagram, those levels are all very, very high up, close to the continuum. So we have a complete radiative model for those. So you can specify which of these these databases to use and then you can specify how many levels to include in the model. It's a compromise. If you include lots of levels, you can get a great big fat calculation. There's a lot of time, a lot of memory, but better fidelity. So it's a judgment call what you want to do here. The database print command described there in Hazy generates a report that can be very useful for understanding what you have in a different way. We're not going to go into the 1 and 2 electron systems in this video. Here they are. Here's an example of some molecules in this output. So there's TiO, PO, uh, and here's some examples of ions. Of ions, we've ended up with aluminum here. So as you see, is it's giving you, in the case of molecules, it's simple. The chemists did not distinguish between spectra and molecules. They have the same name. In atomic spectroscopy, the spectrum has a notation with Roman numerals. We don't use that. We use just the number. So aluminum 1, aluminum 3. And then we have the species, which is the baryon. And so we use the plus notation like that. So this is telling you this is the baryon, this is the spectrum. Remember, it's off by 1 because they didn't count the atom correctly. Next thing you'll notice, the report includes the total number of levels that are available. So some have a lot of levels. Like argon, atomic argon. Who's ever seen atomic argon? In absorption or emission. It's got 500 levels. Wow. We only use by default 15 of these levels. We're not using the whole thing. You can easily change how many levels we use. TiO has 230 levels, makes a very rich spectrum. We're using 70 of those. PO it goes on and on. The important point here, the database has many more levels than we use. It's a compromise we'll talk about next. And there are some cases where our compromise is not good enough. You want to increase the number of levels. So to do that, here's a tiny snippet of that we just saw, the Lambda and Stout databases for some molecules in aluminum. We have a default that's set up that's described in Hazy 12.1.1. For most elements, we use 50 levels if the model is collisionally ionized and 15 levels for the photoionization case. A photoionized plasma is very cold compared to the level of ionization that's present. It's photoionized, not collisionally ionized. A collisionally ionized plasma has a temperature that's about the same as the ionization temperature because it is collisionally ionized. So for a collisionally ionized plasma, much hotter, so you can excite many higher levels. We include more levels for those cases. So the iron is a special case because it has so many electrons. It has a very dense energy level structure. So in collisionization, we use 100 levels and 25 for photoionization. These are very, very simple to change. So there's a family of commands, the species commands that change details about different species. So if you wanted to change O plus to use only 10 levels, you would do that right here. If you wanted to change iron plus 23, so use all the levels we have, you would say levels equals all. We have these different databases, and you can choose to use a different one than we use by controlling the master list. So all 3 of these databases have master lists. It was an idea that we copied from the Chianti database. It's a nice idea, so we have imposed it on all 3. The Stout database master list is in the Stout directory under data in the master list folder, and we used a file called stout.ini. We'll talk about the contents of the master list in a second. Chianti has a master list. It's in data Chianti master list. It's called cloudychianti.ini. Then Lambda has a database, it's lambda.ini. So this file has information about what ions to include in using that database. So for this is, I can tell from looking at it, this is a Chianti master list. We use Chianti for iron quite a bit. And here's a comment in the master list. And here's iron 17. We change the default number of levels by adding a level. So that means without changing anything, if you're on cloudy, it's going to use 30 levels for iron 17, not the default we just said. If you specify the same the same species and all three, it has a priority. So this is the priority. So carbon 2 is probably in all three. So stout, if it's in the stout master list, we'll use stout. If it's not in the stout master list, and if it's in the Chianti list, we use that. If it's not in either of those and it's in lambda, we'll use that. So if it's in all three, we'll use stout. So this is the level of priority. It's a judgment call we had to make. Well, that's a lot of information. The good news here, although you can specify which database and how many levels and get into a lot of details, if you're happy with the decisions we made, you don't need to do it. So you can skip this video. Thank you.